Okay, so doing chapter 10, which is infinite series. We've got Taylor series, Maclaurin series, power series, Lagrange error, convergence tests, all of that stuff. So let's start with this. You need to memorize these 4 Taylor series and their power series, or whatever. These are the 4 you've got to have memorized, because then we're going to manipulate them. You're expected to know them. So one thing that you'll be asked to do is to find a power series by manipulating one of these. And so both review worksheets at the end of your packet are fabulous for this test review, reviewing for the test. 15 on the end there says find a power series for f of x equals x squared over 1 minus 2x. So out of those 4, the one it looks like is, I'm going to use the parent graph that I'll call it g of x, is 1 over 1 plus x, which you'll have memorized is 1 minus x plus x squared minus x cubed, and it keeps on going like that. So that when I'm trying to find f of x, which is x squared over 1 minus 2x, what I'll do is I'll be plugging in a negative 2x into that g function, right? And multiplying that times x squared. And that's what will give me this function. And so I'm going to leave the x squared out front, and I'm going to be plugging in a negative 2x into all of the x's. So a 1 minus negative 2x, and then plus a negative 2x squared, and then a minus negative 2x quantity cubed, and it keeps on going like that. I'll simplify inside the parentheses first, and that'll give me a 1, and then that would be a positive 2x. Squaring that negative 2x will give me a 4x squared. And then cubing the negative 2x will give you a negative 8x cubed, but then you're subtracting it, so that becomes a plus 8x cubed, and it keeps on going like that. And then we distribute the x squared in there, and you'll have a x squared plus 2x cubed plus 4x to the 4th plus 8x to the 5th plus, all right, what's my general term? All right, so to get the general term, what you do is your general term for 1 over 1 plus x was the negative 1 to the nth power x to the nth power. That's your general term for your parent guy, right? But f of x, what we did was we went x squared times g of negative 2x, right? So that would mean I've got a x squared times a negative 1 to the nth power times a negative 2x to the nth power. And so then you end up with a, we can separate this out and make it you've got the negative 1 to the nth power in front. You could actually pull this negative right here, not that one. We can take this and put it as like a negative 1 to the nth power, and then I still also have a 2 to the nth, and I have an x squared, and I have an x to the n. And so these two guys will end up being a positive 1 to the nth power, so we can just ignore it and not include it. But I'll keep the 2 to the n, and then keeping the base out in the exponents makes your general term a 2 to the n times x to the n plus 2. So there's your general term that you must include. There you go. So there's that finding the manipulating a known power series to find some other one. You have to include the first 3 non-zero terms. I gave 1 extra, I gave 4 terms, and then the general term. So, yeah, all of those 4 are good. You're going to manipulate all of them at some point, I'm sure. And the review worksheet has quite a few other problems just like that. We also said you're going to need to build a Taylor series given derivative values. And that is like that review sheet, worksheet number 1, where they say let f of t be a function that has derivatives of all orders for real numbers. They give me that f of 0 is 5, and the first derivative at 0 is -3. So here they give you a bunch of derivative values. The second derivative at 0 is 1. The third derivative at 0 is 4. And they want you to write the third degree Maclaurin. Maclaurin just means that you're centered at, that just means you're centered at x equals 0. All right, so polynomial for f. All right, so here's what we know. We know that the function is found by doing f of c plus the first derivative at c times x minus c, technically over 1, and then plus the second derivative at the center times x minus the center squared over 2 factorial, and then you would do the third derivative, evaluating it at its center, x minus c cubed over 3 factorial, and it keeps on going like that. So that's how you're going to build it, build a Taylor or Maclaurin polynomial. So what I've got here is that they wanted to find f of t, so I guess I'll call it f of t. And then f at 0 is 5 plus, it's a -3 for your next coefficient, so -3 times t. Okay, so technically it's t minus 0, right? But I can just leave t. And then plus a 1 times t minus 0 squared over 2 factorial, and then plus a 4 times t minus 0 cubed over 3 factorial. And it technically keeps going, but for the third degree polynomial, we would just stop right there, right? And so this ends up being a 5 minus 3t plus t squared over 2, and then plus 3 factorial is 6, so you end up with a t cubed, let's see, 2 goes into 6, no, 4 goes into 6, it'll be a 2/3, like that. So there's your third degree Maclaurin polynomial. We can then say use it to approximate the polynomial at f at 2. And that's all you're going to do is just, and then to 3 decimal places, all you're going to do is plug it in. Plug in 0.2. So f at 0.2 would end up being 5 minus 3 times 0.2 plus a 0.2 squared divided by 2, and then a 2 times 0.2 cubed over 3. And if I put it in my calculator right, just put it all in your calculator. Hopefully I did it. I should have double checked it, but I got 4.425 when I did that. All right. The other thing we can do is ask you for the Lagrange error, and a good question for that one was like number 6 on the quiz. So quiz number 6. But here's what you need to know. You need to know that the error is the next term. So if they're asking you for, if they've given you a third degree polynomial, then the error will be the fourth term. So here's, so that's why I knew for quiz number 6, they told us, they gave us a third degree polynomial. They also gave us a maximum for the fourth derivative of f evaluated at x. They said, hey, it's less than or equal to 23. So that's giving me a bound. That's giving me a maximum right there. Yeah. And so your fourth term will be the fourth derivative evaluated at c. Right, or I guess I'll just put x for right now. And then x, this guy was centered at -1, so it'll be a 1 to the fourth power, and then all over 4 factorial since it's the fourth part. And then what we know is that guy is going to be less than 23, and they wanted you to find it for f at -0.8, right? So that's when you plug in that 0.8 into the x, and we add 1 and do it to the fourth power. And then 4 factorial is 24 because it's 4 times 3 times 2 times 1, and there you go. And then you get some decimal value for that. Some things you should know, we expect you to know, you should know things like sine and cosine have maxes. Yeah? We know that sine of x is between 1 and -1, and we know cosine is the same thing. And so what both of those means is the max of sine or cosine is 1. That's the maximum value there. So keep that in mind. Sine and cosine are bounded there. So, all right. Then we can also do some little weird stuff like still using the same thing of building these polynomials, right? Number 2 on the review worksheet says, let f be a function having derivatives of all orders for all real numbers, and they give us the 5th degree Maclaurin polynomial for f is given by, that's this notation for 5th degree polynomial, 1/2 x to the 5th minus 2x to the 4th minus 4x cubed minus 8x squared plus 10x minus 2. And they wanted you to find a bunch of the derivatives evaluated at 0. I'm just going to I'm just going to do one of them because you do the rest of them the same way. I'm going to do the hardest one. Let's find what the 5th derivative of f evaluated at 0 would be. So the first thing is, let's rewrite this so that, like the Maclaurin polynomials we're used to seeing, where first you've got a constant, and then you have the linear term, the x to the power of 1, and then you had the squared term, and then you had the cubic, and then you had the x to the 4th term, and then you had the x to the 5th term. Right? We always started with a constant and then built it up. So I'm just going to rewrite it so that it's obvious, yeah? And so what I know is that the coefficient, when I'm building these polynomials on the x to the 5th term, you would, if you were building it from scratch, it would be equal to the 5th derivative at 0 all over 5 factorial, right? Because the term itself, if you remember, the term for the 5th degree term would be, you would have done the 5th derivative, evaluating it at c, right? Which in this case is 0, and then you would have had an x minus c to the 5th power all over 5 factorial. That's how we were getting the terms, right? But your c is 0 here because it's Maclaurin, and so that's how I know. The coefficient would just be the number in front of it, right? There's your coefficient. So that's where I'm getting that. But we were given the coefficient on x to the 5th. It's 1/2. 1/2 is equal to the 5th derivative evaluated at 0 over 5 factorial. So you just want to solve for the 5th derivative by multiplying both sides by 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. So is that 120? 120 times 1/2 is going to equal the 5th derivative evaluated at 0, which means that it's 60. So 60, whoops, 60 is your answer. All right. That one. And there's a whole bunch of other problems just like that on this. Both review worksheets are incredible. I would be doing all of those again. All right. We also asked you to find, so given a power series, finding the interval of convergence of the power series. So I'm going to do number 6 on the review worksheet, where the power series they gave you was from n, it goes from 1 to infinity, and it's a -1 to the nth power times x minus 1 to the nth power all over 2n. And if you write out a few terms, so that's what they wanted you to do. They wanted you to write out a few terms, and this would be a negative x minus 1 over 2. And then a positive x minus 1 squared over 4. And there'd be a minus x minus 1 cubed over 6. And it keeps on going like that. These power series definitely converge at the center. And the center, since we have x minus 1, converge at the center is at x equals 1. So you can test that by plugging in. When you plug in a 1 into all of those x's, you would have a 0, and then plus a 0, and plus a 0. Yeah, definitely converges. That converges to 0. Yeah. So, but what we want to know is where else? Where else does it converge? Yeah. Sometimes it only converges at the center. Sometimes it's got a radius of convergence. Sometimes that radius is all real numbers. Sometimes it's a limited thing. Sometimes if the radius is 0, then that means it only converges just at that center. But how you find it is you do the ratio test of doing the n plus 1th term divided by the nth term. So when you plug in the n plus 1th term, so technically it's a -1 to the n plus 1, x minus 1 to the n plus 1, all over 2. So I'm plugging in an n plus 1 into every n. When you divide by the nth term, that's the same as multiplying by the reciprocal. So I'll multiply by the reciprocal of my nth term, which is a 2n over -1 to the nth power times x minus 1 to the nth power. All right, we're taking absolute value. So these -1s just don't even matter. We're taking the absolute value of it anyway. But then when you go to simplify these guys, you end up with the limit as n goes to infinity of, you've got a 2n and a 2n on top and a 2n on the bottom. L'Hopital's would prove it. Not that you have to do that on the test, but when the degree on top is the same as the degree on the bottom for these n's, then as n goes to infinity, the limit there of 2n over 2 times n plus 1 will be 1. And so what you're left with is x minus 1 to the n plus 1 divided by x minus 1 to the nth. And so you're left with just x minus 1. And there's no n's, right, anymore. And so as n goes to infinity, you're just left with the absolute value of x minus 1. Now, when does this converge? This converges when, so we want, when does this value, when is it less than 1? So when is absolute value of x minus 1 less than 1? To remove absolute value, you just put them in between the positive and the negative. And then you add 1 to both sides, or all 3 sides, I should say. And you get that this interval is from 0 to 2. Now, you absolutely must check your endpoints. Check your endpoints, because we might include them, and we may not. So at x equals 0, what do I have? I end up having a -1 to the nth power times -1 to the nth power all over a 2n, which ends up giving you a +1 to the, well, I guess I should say it's a -1 to the 2n, right? But that ends up being a +1. Now, I guess I should have showed that. It's truly, that's really a -1 to the n plus n, which is a 2n, but then -1 squared is a +1 to the n. So that's how I got that, just in case. All right, so what are we left with? Well, 1 to the n is always 1. So you're just, you have 1 over 2n, and that's 1/2 times the harmonic. That is the harmonic series, and it diverges. And so you're not going to include the 0 as at an n, you're not going to include 0 there. And at x equals 2, you would have a -1 to the nth power times a +1 to the nth power over 2n. And that is still, that leaves you with a -1 to the nth power over 2n, which is an alternating. It's an alternating series where, I mean, it's 1/2 times the alternating harmonic series, which definitely converges. It's alternating. The limit as n goes to infinity of 1 over 2n is 0. Yes, the terms are decreasing terms, and so this converges by the alternating series. So I'm not going to include 0. I am going to include 1, and so my interval of convergence is soft parentheses on the 0, but a hard bracket on the 2. All right. What was that one? That was number 6. Okay. There's more types like that on the review worksheet. You should find it. The radius of convergence was 1. Your center is at 1. Radius of convergence is 1. You can see that by, like, here's your center is 1. The radius was 1, which made you go out to 2. And the radius here was also 1, which made you go to 0. So that's that interval, not including 0, but including 2. You're going all there. So that's the whole connection between center and radius, and then interval of convergence. Okay, We're also going to ask you to approximate the area using a power series. So that's like number 16 on your review worksheet. It says use a power series. Use a power series with 3 terms to approximate the shaded region below, which means the area, right? And the picture they gave you, something like that. It was all this shaded area here. And they gave you the f of x is cosine of rad x. So they'll give you the function like that. So what are you going to use? You are going to use the power series you know for cosine, right? We know cosine of x is the parent graph is, or parent series, right, is 1 minus, it's all the even powers. So x to the 0 would give you that 1, and then x squared, and then x to the 4th over 4 factorial, and x to the, next one would be x to the 6 over 6 factorial, and it keeps on going like that, right? So that means that cosine of rad x is, you would just plug that in. Plug in rad x into all of those x's. We're manipulating this series. We know cosine, and so cosine of rad x, we can manipulate it. Minus. Okay, so we got all that, right? So then that means that it ends up being a 1 minus x over 2, and then plus an x squared over 4 factorial, and a minus, that ends up being an x cubed over 6 factorial. Yeah. All right, so our limits, how we figure out, so to find area means you're going to use integrals, right? Find the integral of this function. We're going to use power series to do it. So for your limits on the integral, what you want is when x is, well, you want where the graph is crossing the x-axis. Well, it's starting here that's at x equals 0. And then I also need this x-intercept right there. So the limits will be x is 0, and then also when cosine of rad x is 0. Well, that means that rad x is your angle. I know that looks weird, but and then we'll have inverse cosine of 0. So when is cosine 0? Well, at pi over 2, yeah, which then means that x is equal to squaring both sides, pi squared over 4. So that'll be your upper limit. So the area underneath that curve, or the shaded area, is going to be the integral from 0 to pi squared over 4. And then just evaluate that power series. 1 minus x over 2, and then plus x squared over 4 factorial, and minus x cubed over 6 factorial. Do I even need that? How many did they tell me? I only need 3 terms. I have too many. Well, I'll leave it for right now, and I can always get rid of it. All right, dx. All right, reverse pop and drop. It'll be an x. That'll be a x squared over a 2 times a 2. All right, and then x squared, add 1, so now you'll have a 3, and then but divide by 3 to undo that, times 4 factorial, and then minus x to the add 1, 4, but divide by 4, and it keeps on going like that, and we're going to be evaluating that from 0 to pi squared over 4, and then only using 3 terms. Yeah, I don't need this guy. Don't give me too many terms. If we're saying 3 terms, I'm scratching that one out because just 3 terms. It says use a power with 3 terms. So I only need those 3. And you're going to be plugging in the pi squared over 4 into all of the x's. What does that become? That ends up being a pi. I'm just going to do math magic and you guys can verify it. But pi to the 4th over 64, and then a pi to the 6th over 4,608, and you end up getting, using 3 terms, 1.154 to 3 decimal places. All right. You're also going to need to verify that the derivative is true using using power series. So a good one on that is the quiz number 14, where they want you to show that the derivative of cosine is negative sine. Now obviously you know this, right? I'm giving you the correct answer. So what is this question asking you to do? It's asking you to show. So you better show every step, right? If in doubt, show it, because otherwise you'll lose points, right? So what I'm going to do is I'm going to start with cosine of x. What's the power series for cosine of x? It's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And then I'll stop there and go plus dot dot dot. What's the general term? It's negative 1 to the nth power times x to the 2n all over 2n factorial. And obviously it keeps on going like that. All right. So let's take the derivative of it. Derivative of cosine would be show this work, right? This is the part of don't just jump to negative signs power series, because if you know, yeah, it would be cheating. Okay, so derivative of 1 is 0. Then you have a pop and drop, 2x now to the power of 1 over 2 factorial. Then you would have a 4x cubed over 4 factorial. And then minus 6x to the 5th over 6 factorial. Let's do the general term also. Negative 1 to the nth power. Pop and drop would say take that exponent, bring it around front, drop the exponent by 1, and then 2n factorial is a constant down below. And we still have All right, so there's the derivative. When we simplify this, you end up with a negative x and then plus a x cubed over 4 factorial is truly, I should write this down here. 4 factorial, remember, is 4 times 3 times 2 times 1, which also means that it's 4 times 3 factorial. Yeah? So if I have so that means when I have a 4 over 4 factorial, it truly is 4 over 4 times 3 factorial, and the 4's cancel, so that you're left with just a 3 factorial on the bottom. Yay! Okay, so that's where I'm going to come up with that it's x cubed over 3 factorial is what's left. And then a minus x to the 5th over, same reasoning, the 6 cancels, you're still left with 5 factorial. And then what to do with this general term? Well, I've got the same thing, again, I'll do this down here too. 2n factorial would be 2n times 2n minus 1 times 2n minus 2, all the way down until you got to 3, 2, 1, right? Which also means that when you've got it's also equal to 2n times the very next term, lower factorial. So that means that when you've got this 2n on top and a 2n factorial on the bottom, you're going to be left with a 2n minus 1 factorial on the bottom. And then we also have the x to the 2n minus 1. All right, when you factor out, okay, and then let me just do a side note real quick. I know that's not the way you memorize sine, but sines, well, here, no, I'll wait until I write sine. All right, so what do we know? If I factor out a negative from here, then I'll be left with an x minus x cubed over 3 factorial, and then a plus x to the 5th over 5 factorial, and then a minus and a bop, 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 and then, yeah, I'm going to leave it, and it's okay. And here's why it's okay. It's not the exact same as sine, right? Sine's power series is actually, so sine's power series, sine of x, the general term is actually it's the power series of -1 to the nth power, but you're starting with 0, right? And it's x to the 2n plus 1 all over 2n plus 1 factorial, right, to infinity. So the only difference here, and it's because we took the derivative, so it changes the index in a power series. I know we didn't go over that, but my point is this. You don't have to worry on the fact that these are different. This general term is when you start your index at 1. And if you start it at 1, you will see that they all match up and everything is golden. So I can claim that this is equal to negative sine of x. Check. So I know that one part is a little bit funky, but odd numbers come from both 2n plus 1 and 2n minus 1. All odd numbers, that's how you get them. And it all depends on what starting number you want to start with, if you're wanting to start with a 1 or a 3. And so anyway, that's why if you start it with a 1 for 2n minus 1, anyway, that's the reason why. So, but it's okay, not a problem. My point is, make sure you show the steps of taking the derivative there. Okay, and then you're also going to need to build a polynomial from scratch, and that I will do one like. I'm going to build a Taylor series from scratch. This is like the review worksheet number 10. We want to find the Taylor series centered at, okay, so for f of x equals the natural log of 4x and centered at c equals 1. Okay, so this is where you build it. You start going, all right, what's f of x? Well, f of x is just the natural log of 4x. So what's f at 1? Because you evaluate it there. Well, that would be the natural log of 4. Then you find the first derivative. And the derivative of natural log of 4x would be a 1 over 4x, but then chain rule says times 4, right? Because you would need to take the derivative of the 4x, right? Well, that's just a 1 over x. And so the first derivative evaluated at 1 would just be a 1. And then second derivative would be a negative 1 over x squared. And so evaluating that at 1 will be a negative 1. I'm going to ask you to give the first 3 non-zero terms and then the general term, okay? So let's keep going. Find the third one, and that would give you positive 2 over x cubed, and so that one evaluated at 1 would be a 2, and let's go ahead and just find the fourth derivative also. And that would be a negative 6 over x to the 4th. I'm obviously not showing those. Hopefully you remember how to take the derivatives. Just change the 1 over x to an x to the negative 1, right? And do pop and drop. Change this negative 1 over x squared to a negative x to the negative 2 power, and then do pop and drop. So evaluating that at 1, you'll get a negative 6. All right. So remember, these Taylor series are always, it's the, your function is going to be approximated by the first term. So write this, yes, let's write it. How about I write, it's always going to be, you're going to go, I'll call it the polynomial, right? Okay, so it'll end up being f at, well, technically it's f at c, and then plus f prime at c times x minus c over 1, and then plus the second derivative evaluated at c times x minus c squared over 2 factorial, and then the third derivative evaluated at c times x minus c cubed over 3 factorial, and you keep on going like that, right? So that's what we're going to use these values to plug in. So the Taylor series for this guy would end up being natural log of 4 plus 1 times x minus, what's my c? It's a 1. And then my next term was a negative 1 times x minus 1 squared over 2 factorial. And then it was the third derivative at 1 was a 2 times x minus 1 cubed over 3 factorial. And then the next one would be negative 6 times x minus 1 to the 4th over 4 factorial. Okay, and it keeps on going like that. All right, so I can simplify these. This is the natural log of 4, and then plus x minus 1. What would that be? Minus x minus 1 squared over 2, and then the 2 cancels with the down on the bottom, so x minus 1 cubed over 3, no longer a factorial, minus the 6 is the 3 factorial, so you end up with just 4, no more factorials, right? So there's the first 3 non-zero terms. I've given too many, but that's okay. And then we do need to include the general term. So what ended up being the general term? Can you tell? By the way, it's okay if this constant doesn't really match your general term guy, right? But we definitely have alternating terms, right? We definitely have negative 1 to the nth power if we're going to start at n equals 0, right? Or are we going to start with n equals 1? Let's see what happens. I might change that. And then, oh yeah, plugging in a 1, starting with a 1. That first guy's positive, so I'm going to do an n plus 1 because you need it. When n is 1, you need it to be a positive value. Right? And then we have an x minus 1 to the nth power, and then over n. And that's your general term. So I changed that n plus 1 because I'm ignoring this first constant because it doesn't really match anything else, and that's okay. It's not a big deal if the first term doesn't match the rest of the terms. But if it's weird like this, see, there's no way to get the natural log of 4 from it. So it's like the natural log of 4 and then plus the rest of this. But notice that as soon as I plug in a 1 into n, I need a positive in front of there, and I need the negative when I plugged in a 2, which is why I chose the n plus 1 exponent on the negative 1. Okay. That is all for the one part of the test where it's everything but the convergence test. This is all the Taylor polynomials, Maclaurin polynomials, power series, Lagrange error, all of that. That is all of that. All right, then on the other day of the test, it is the all of the convergence tests. So the convergence tests. You're going to get lots and lots and lots and lots and lots of stuff, yes? All right, so I'm going to be doing things from the review worksheet that is actually called, it's got a weird name, the Convergence Practice Exam. Convergence Practice Exam worksheet. When I say this is from the review worksheet. Okay, so I'm just going to do a couple of them and hopefully, and then kind of talk you through a few things, and then it'll be it. Okay, so let's do number 8 on that worksheet. And we want to say, does 4 to the nth power over n factorial converge or diverge? Yeah. And so you're going to have to state the test you use, right? State the test, and then say converge or diverge. Okay, so you got an n factorial there, which is perfect for ratio tests. So I'm going to use the ratio test, which is the limit as n goes to infinity of the n plus 1th term, so 4 to the n plus 1 over, this would be an n plus 1 factorial. You've plugged in n plus 1 every time you saw an n, and then times, because I'm going to divide by the nth term, so I'm going to multiply by the reciprocal, so this ends up being an n factorial over 4 to the n. All right, so that ends up giving you the limit as n goes to infinity of the, you end up with a, remember, n plus 1 factorial is equal to n plus 1 times n minus 1 times all the way down. But all of those guys are n factorial. So you end up with an n plus 1 in the bottom, and you simplify that. And then the 4 to the n plus 1 divided by 4 to the n will leave you with a 4 to the power of 1, and or 4 to the power of 1 up there, just using properties of exponents, right? Well, as n goes to infinity, that's 0. And that is definitely less than 1, which means that this guy converges. So you need to show your work, you need to state the test, show your work, and then say that it converges. Let's do one like 14. But I'm going to write it a little bit different. Not that you shouldn't know 14 how it is, right? I'm going to rewrite it though. I'm going to rewrite it as this is equivalent to 2 over n times n plus 2. Yeah? Because if you have 1 over n minus 1 over n plus 2, common denominator, your n's end up canceling. Yeah, so you end up with 2 over that guy. Okay, so just what happens when you just see this? Well, you would definitely use, like the way it sat to begin with, you would definitely use telescoping. So this is a telescoping series, but you'd have to do partial fraction decompt in order to get it into the original one that 14 gave you. But if it's just like this, then what you can do is compare it to 1 over n squared. Yeah, do a comparison to 1 over n squared, which is one we know, so this is the limit comparison. limit comparison test is the one I'm going to do. And I know 1 over n squared converges. Right? So I'm going to take the limit as n goes to infinity of 1 over n squared over 2 over, I'm going to go ahead and distribute that. That's an n squared plus 2n. By the way, that's how I knew that I should compare it to n squared, right? Because this guy would be an n squared plus 2n. So you've got a 2 over n squared plus 2n. Yeah. All right, so then I'm taking the limit of these two guys, which means that it's the limit as n goes to infinity of, it would be n squared plus 2n over 2n squared. And now you've got degree on top is the same as the degree on the bottom, and so the limit as n goes to infinity is the leading coefficients, which is 1/2, and that is a finite number, and so that means that this one converges also. So limit comparison is what I used on there. Could have done telescoping, but I would have had to do partial fraction decomp first. 14 as it sits is also a good one to look at too. Practice those telescoping by expanding it out and doing it. But be careful because, 14 looked like that. Here was the original 14, right? Here was the original 14, looked like that. And so this guy is telescoping, but not all function, right? Not all, if they've got the series and you've got a function minus some other function, not all of these guys will telescope, right? There are ones that won't telescope, so you got to make sure you start expanding it out and see that terms are actually canceling. Telescoping means that terms will cancel. I can give you, I think I have an example of one that doesn't do that. It's like, here, let's go to, on your homework, page 102, homework number 11, it looked like this. 1 over n cubed minus 1 over n squared. That does not telescope. The terms don't cancel. I know there's a squared on there, but regardless, right? They don't cancel. So be very careful. Yeah? What I would do on this guy is I would rewrite it so that it's a single fraction. So you would have a 1 minus n over n cubed, just by getting a common denominator on that second one. And then that would be equivalent to 1 minus 2n plus n squared over n to the third to the second, so to the sixth. And then now you've got a single term in the bottom, so you can separate that, right? And that ends up giving you a 1 over n to the sixth, and then a 2n over 6n to the sixth. So that n on top cancels, so you got an n to the fifth, and then a 1 over n to the fourth. Go away. 1 over n to the fourth. And how would I do that one? Well, I would do the integral test. Yeah. This would, by the integral test, you can show that the integral of 1 over x to the 6th minus 2 over x to the 5th plus 1 over x to the 4th dx from 1 to infinity, it'll end up, you do a bunch of math magic, right? Can I do math magic? You end up having negative 1/5 x to the negative 5, and then a plus 1/2 x to the negative 4, and then a minus 1/3 x to the negative 3, and you'll evaluate that from 1 to infinity, and when you plug in the infinities, you're going to have a 0, plus a 0, a negative 0, plus a 0, minus a 0, doesn't matter, they're all zeros, and then a minus, and then a negative 1/5, then a plus 1/2, and a minus 1/3. So then you end up with 1 over 30, which is a finite number, which means it converges. Yeah, converges, I didn't say, oh yeah, integral test is what I used. By the way, the other thing you could have done is, that's a converging p-series. That's a converging p-series. Converging p-series. Yes, all of those are converging p-series. And it does turn out that if a series converges, then there's some converges also, if, you know, so a converging series minus another converging series plus another converging series will also be converging. So that's just another way, the lazy way to approach it also. But okay, so we have that. Then there was something else I wanted you to be careful about, and that was it? Oh yeah, I know what it is. Okay. Let's look at, on your homework on page 109, number 6. Not all alternating series do I have to give you a -1 to a power, right? I can give you something like cosine or sine instead. Right? Cosine of n times pi over n squared. Yeah. Okay, so there's that series. So what you want to do though is you want to start checking these guys out, because cosine, there's a way for us to give you, normal cosine oscillates, right? It goes +1 and -1, like with powers of pi, right? So this guy was, when you start with 1, you'll have cosine of pi, which is a -1, and then the next one would be a 2 pi, which would be +1, and then -1, and then +1, right? So this is when n is 1, and when n is 2, when n is 3, you would have -1. When n is 4, you're going to have +1. So it's the same thing as -1 to the nth power, just a fancier way to write it. Right? So that makes this guy definitely an alternating series. Because the terms end up being, the first term will be negative, second term will be positive. So it's definitely an alternating series. You see, does this 1 over n squared, does it go to 0? And sure enough, it does. And then are the terms decreasing? This is the notation for it, but that just means terms are decreasing. And so, yep. And so that means that this guy converges. And it's we use the alternating series test. But be careful. Make sure you expand those cosines out, right? Because you could get an alternating series, but not always. Had this been a cosine of 2n times pi, right? That guy, when n is 1, you're going to have 1. And when n is 2, you got 4 pi, so it's +1. And when n is 3, you've got 3 pi, or sorry, you would have 6 pi, which is also 1, right? So this is always 1. So it may look complicated. Make sure you check it, right? Make sure you check. Don't always assume that sine and cosine alternate. They can, right, depending on what we give you. It can be the substitution for a -1 to the nth power. But make sure you plug in a couple values, see what's happening, make sure if they're alternating or staying the same sign or whatever. Okay. I want to make sure that you know the difference between, which one was the good one? Let's see. Oh, yeah, let's look at number 12 on that worksheet. It says 4/2n minus 1. All right. Now listen, this is important. Super important. This is not a harmonic series. Harmonic series is 1/n. It's not a p series. A p series is 1/n to the p. What's messing it up? That -1 right there in the bottom. That guy right there, messing it up. It is no longer a p series because of that 2n minus 1 in the bottom, right? So it's wrong to say that this guy diverges because it's harmonic, or it's wrong to say it, you know, it's totally wrong. Same thing with, I feel like there was one on the quiz, like if you have a 3/n squared plus 4, that is not a p series, because of that plus 4 in the bottom. The 3 on top's not a big deal because you can multiply a constant times any of the functions, right? So it's not, this 4 isn't a big deal. The 2 in front here, not a big deal. Constants, no big deal. It's the subtracting of the 1, right? Or it's the adding of the 4 down there. They're no longer a p series. So what you do instead is you compare it to. Instead, you do a limit comparison test to the p series, or to the harmonic, which is a special type of p series, right? So that's, I want to be real clear on that. Make sure, don't claim that it's a p series because that's wrong. It's not a p series, but you are going to compare it to a p series, and then it's going to behave the same, and then beautiful, wonderful, love it. All right, so what am I going to do? I'm going to do the limit comparison test. Yeah, and I'm going to compare it to, for this guy I would compare it to 1/n, which we know is the harmonic series, which diverges, because p is 1. And so you take the limit as n goes to infinity of your known guy over this guy, right? And that's the limit as n goes to infinity of 2n minus 1 over 4n. Yeah. And as n goes to infinity, you are left with what's the leading coefficients, right? Because you got an n on top to the power of 1 and an n on the bottom to the power of 1. So you're left with a 2/4, which is 1/2. And so it does the same thing as the one you compared it to. It diverges also. So that guy diverges. All right. Make sure, how many more of these do I want to do? Let's do a root test. That sounds good. A root test, we'll do number 6. So when do you do a root test? When you've got some, variable to the nth power, right? And n equals 1 to infinity. Okay, so I would definitely try the root test, which is the limit as n goes to infinity of the nth root of, take the absolute value, of the 2n over 3n plus 1 to the nth power. Nope. I wrote the problem wrong. This is a 2n. There we go. Okay, so what are you left with? Well, the nth roots cancel. The nth root cancels with the nth power. And so you're left with the limit as n goes to infinity of 2n over 3n plus 1. I'll move the squared inside. Not that it matters, but and so what happens when n goes to infinity is hopefully you see it. The n on top and the n on the bottom will cancel, except that you got a squared here, so it's not just the leading coefficients, it'll be a squared. How about I show you by expanding it? I know this is a pain, but I just want to make sure you know where it's coming from. This would have been a 4n squared if you squared it. This would have been a 9n squared plus 6n plus 1. All right, is that better? So now you've got n squared on top, n squared on the bottom. So what are you left with? A 4 over 9. That is smaller than 1, and so this guy does converge by the root test. Okay. Yeah, all of these problems on these worksheets are fantabulous. I won't go over that one because I already kind of went over that. Like number 10, that's great. There's another example of sine. And does it end up being alternating or no? Check it out. It does, but spoiler alert, but just in case. How about make sure you check if it's just the nth term test, right? Sometimes it's a matter of, hey, just do the nth term test. N over 3n minus 1. There we go. All right, so if I do the nth term test, that means I'm taking the limit as n goes to infinity of n over 3n minus 1, and that ends up being a 1/3, which is definitely not 0. And so it definitely diverges. I would do a quick check of that always, seeing if the nth term, does it fail the nth term test? How about another ratio test, like number 4, 3 to the n over n cubed from 1 to infinity. So there's another ratio test that would be good for the ratio test. Limit as n goes to infinity of n plus 1th term would be 3 to the n plus 1 over n plus 1 cubed. And then you're dividing by the nth term, so you got to multiply by the reciprocal. And the n cubes, as n goes to infinity, those end up being 1. And so you end up with the limit as n goes to infinity of 3, right? So that's just 3, which is bigger than 1, which says this one diverges. Yes. Okay. I think that about covers it. I think so. Some things just that you should know. If you say telescoping, then that means it converges. Yeah. If it's diverging, it's not telescoping. Because to telescope doesn't mean you're just, adding and subtracting things. Telescoping means if it's diverging, it's not telescoping. If it's telescoping, it means that things are canceling, right? And so, and when they cancel, then it converges to whatever is left over, right? And it converges to what's left after canceling. All right, so telescoping is the one that it doesn't diverge or converge. And same thing with nth term test. That's a divergence test, not a convergence test. And then, okay, this may sound stupid, but just so you know, just some things, you know. E is a number, right? It's about 2.7. E to the 0 would be 1, because anything to the 0 is 1. You know pi is about 3.14. All of these things are numbers, right? They're not variables. So be careful with that. And on the quiz, you had to do partial fractions to change a series that did not look telescoping into something that's telescoping. Monday is the quiz. There you go. It was. Whoops. I go too far. Okay. I'll do one more and then I'll stop. Quiz number 5. It says, which of the following gives the sum of the it says you're telescoping, of the telescoping series 4n minus 1 times 4n plus 3, right, from n equals 1. And you probably looked at that and went, what? That's not a telescoping series. I'm not having things. Are there? Is it adding and subtracting if you just plug it in? That would be funny if it does. Does it? If I plug in, I didn't check that. 3. No, you get a positive number plus another positive, right? All right. Yeah. All right. So this is a hidden little telescoping series that it does end up converging. You do partial fraction decomp to have it happen. Right, where you go 9 over 4n minus 1 times 4n plus 3. That's equal to, put placeholders for the numerators. Multiply both sides of the equation by the common denominator. You'll be left with a 9 equals a times 4n plus 3 plus a b times 4n minus 1. And so then you let n equal, I'm going to let it equal. Let's see, let it equal. You want to let it equal something that'll make it 0. So if I let n equal 1/4, then the b will 0 out. You'll be left with a 9 equals a times 4. So that your a ends up, when you solve for a, you get 9 over 4. And then when n equals, if you have a negative 3 over 4, that's what would get that guy to be 0. So 9 equals b times negative 4. So that b ends up being a negative 9 over 4. So that this ends up being equivalent to 9 over 4 over 4n minus 1 plus negative 9 over 4 over 4n plus 3. So now that's your series, right? Here's your, you're going to replace it. So this is equivalent to, starting with 1 to infinity, of 9 over 4 over 4n minus 1 plus negative 9 over 4 over 4n plus 3. And then you start plugging values in, right? I'm going to come down here. So now I'm going to come down here and start plugging values in. And when you plug a 1 in, you're going to get a 9 over 12, and then a minus 9 over 28, and then a plus 9 over 28. Ooh, nice. And then a minus 9 over 44, and then a plus 9 over 44, and then a minus 9 over 60, and hopefully you get the point, right, that bye-bye, bye-bye, ta-ta. See ya later. And so it converges to what's left over, 9 over 12, which of course reduces to 3 over 4. That's how you figure it out. Okay, there you go. Good luck on your test. That's chapter 10, infinite series. Ta-ta-ta.